Alright guys, in this video we're going to be looking at completing the square even more, but we're going to be looking at examples where we have a trinomial where our a value here is not specifically 1. So the problem here is that if we're going to complete the square, we need a to equal 1. And so in order to get this a value of 1 that would give us something like this, where our c value, we could make it half of our b value squared, what we're going to have to do is we're going to have to factor out the a value that currently exists there instead of a 1. So let's take a look at 3 examples here. We'll look at this first one here. But basically, we're going to treat this the same way we do any normal completing the square problem, by displacing the loose constant here. So I'm just going to go ahead and rewrite this as 5x squared minus 10x, and I just want to simply state that this is equal to 21. The thing here is that I need a 1 right there. So we're going to factor out 5. And so the way this would look is just like when you factor a GCF here. We're going to take this out in front, and what I get left with is x squared, negative 10x divided by 5, that'd be a negative 2x. And what I want you to notice is that I'm going to put my plus blank here inside the parentheses. And the reason why is because explicitly now I'm going to find the c value that I want here, because my a value on the inside here is 1. So in terms of what I want to put in here, since my b value is negative 2, we'd say, well, then my c value that I want is half of negative 2 squared, which really is a negative 1 squared, which is 1. So, yikes, that just looks bad. There we go. So we'll put a 1 here. Now the thing is, what you add to the left side, we have to add to the right side. You guys, you got to do this. So here's the deal. Am I adding 1 to the left side is my question. If I take 5 times x squared, I get 5x squared. And if I take 5 times a negative 2x, I get negative 10x. The thing here is, if I take 5 times 1, really what I've added is not 1, but 5 times 1, which is really 5. So instead of writing a 5 on this right side, what I'm going to recommend that you do is this. You're going to write 5 times whatever goes in this blank, just like you did over here. You write 5 times whatever goes in this blank. So what I put in there was definitely a 1. And so that's just something we're going to have to multiply first before we add it to our 21. But the neat thing about it is, once you get this form, remember that this thing collapses into a factorable square. And not only that, we put half of our middle term in here in its factored form. Now the right side, as far as what we get there, we get 21 plus 5 times 1, which is really 21 plus 5, or 26. So at this point, we could solve this using square roots. Now, what makes this a little bit different when you have a values that are non-1 is that before we take a square root of both sides, remember that we have to isolate the thing being squared by dividing both sides by 5. So what I end up with now is x minus 1 squared, and on the right side, this is not going to bother us, okay? We're fine with this, but we just get 26 fifths, and we're going to leave it that way. So to carry out the rest of this process here, since we have our square thing by itself, we'll just take the square root of both sides, and what I end up with is this. Now notice that I'm splitting my radicals up, okay? And I end up with that right there. Now, one thing that I can tell you is that we need to rationalize the denominator. That is to say that if you've ever taken, like, especially a geometry course before, then you know that you can't leave a radical in the denominator. So the way we're going to do this is we're actually going to take the top and bottom of this fraction times the same number so that we don't really change its value. And what we're going to do is we're going to multiply both by whatever the square root of the bottom was. And the reason why is because, hey, when I take the square root of 5 times the square root of 5, that's really the same thing as the square root of 5 times itself, or the square root of 5 squared, which comes out to be 5. So what I end up with is instead this. I get x minus 1 equals plus or minus all over just a 5 now, the square root of 26 times 5, which, by the way, just so you know where I'm getting my number from here, I'm not just doing mental math. 26 times 5 is 130, but I just wanted to show you. So I'm going to get the square root of 130 over 5. So now the last thing that we'd be responsible for doing, of course, to get x by itself is just carry this 1 over. And so what I end up with for my solutions here are 1 plus or minus the square root of 130 over 5. Now I'm going to put a box around this, and I just want to go to show you guys here. If I were to evaluate this, suppose I get 1 plus, and I have to put this in parentheses, the square root of 130, that divided by 5, so I had to cap off my square root first, and I'm going to end this here. So we're taking 1 plus whatever this divided by this is. Our calculator has to do that first, so that's why I put parentheses around that. And I'll hit second enter to bring this back up, and we'll just go back and we'll change addition relationship to a subtraction relationship. Looking at this here, I get about 3.28-ish and negative 1.28-ish. But what I wanted to do was I wanted to go graph this quadratic function for you to show you that these are actually the zeros of the function, or the x-intercepts of the function, or the roots, or whatever you want to call them there, solutions. But as I graph this, we got a couple of decimals, and one looks like between negative 1 and negative 2, and the other one looks like 1, 2, 3, and 4. Between 3 and 4, if I were to quit out of this, here's our one between negative 1 and negative 2, and here's our other 0 between 3 and 4. So this definitely works out for us here. I'd like to try this again with a couple more of these, but let's start with this 26 that you see over here on the right. So again, let's displace the constant if it's not already on the right side. So we get 7x squared minus 14x is just equal to our 56 here. Now the clutch thing, the key thing here is that I need to have a 1. So just like we did last time, let's just go ahead and factor out a 7. And what I get left with then is x squared minus 2x plus blank. And this is going to be equal to 56 plus, and notice what I'm going to write here, 7 times the very same blank. So in terms of what goes in the blank here, we'll notice that your middle term is negative 2. So we want our c value, of course, to be half of our middle term squared. Half of a negative 2 is a negative 1, and a negative 1 squared is a 1. So I'm going to add a 1 here, and I'm going to add a 1 here. And the neat thing about the left side is, again, because we've forced this into being a perfect square trinomial, now it does factor into this, where our middle term here, if we cut that in half, that's what goes in our factored form. Now the right side, we get 56 plus 7, which last time I checked was 63. So the neat thing about this one is it's a little bit cleaner in that when I divide both sides by 7 this time, look what you get. Oh, you're welcome. You get a 9. The reason why I say you're welcome is because, of course, we would take the square root of both sides next here. So we have this x minus 1 equaling the square root of 9, which, by the way, is, of course, plus or minus 3. And so as I add 1 to both sides here, we get x equals 1 plus or minus 3. I'm going to throw a box around this, but what I want you to understand is that we can actually simplify this here. And so I do want to do this as two separate answers here. I get 4, and in this case I get x equals 1 minus 3, which is a negative 2. And so again, what I do want to go and show you is if I were to go graph this function right here, let's see if we do get the intended solutions or zeros here. We got, suppose, 7x squared is our function, 7x squared, minus 14x's, minus 56 constants. As I graph this here, look where we have a parabola cross at negative 2 and positive 4. Okay? So for this last one here, what I wanted to look at is something a little bit different from the first two in that it just doesn't have a 0 on the right-hand side. Is that going to ruin our day? No, it's actually not going to ruin your day. Again, completing the square is a whole process of getting rid of the constant that already exists and putting in place the constant that you would rather have. So 2x squared minus 4x is equal to 6 minus 5, which is just a 1. And so from here, again, remember that we have to have a 1 in front of our x squared. So here's my 1. By factoring out the 2, I suppose what I get left with is, let's see, negative 4x divided by 2 is a negative 2x. And the most important part is that we're filling in this blank right here to put in the desirable value. So again, remember when your a value is not 1, okay, we have to put in that a value times whatever we're putting in this blank here. So I'm going to write plus 2 times whatever goes in this blank. And it looks like I'm really picking on negative 2 here. I'm not trying to, but half of our middle term is negative 2 over 2 squared, okay, which is really a negative 1 squared, which is 1. So we'll throw a 1 on both sides. In this case, I would get 2 times this factored quantity, which half of our middle term that goes in here would be a negative 1. And on the right side, of course, I'd have to do my multiplication first here, which is 1 plus 2. I would get a 3. So to finish this off, let's go ahead and get the squared thing by itself. We do need to divide both sides by 2 before we can take a square root. But now that I have done this, let's go ahead and take the radical of both sides. So knowing what you know about radicals of fractions, we're going to put plus or minus, but we're going to split this up as the square root of 3 over the square root of 2. And while we're at it, we're going to rationalize our denominator here. So what we get is really just x minus 1 equals plus or minus the square root of 3 times 2, which is the square root of 6, all over 2. So to fulfill our duties here, we'll add 1 to both sides. And what I end up with is just 1 plus or minus the square root of 6 over 2, which does present us with a couple of real results here. So just like in my last video, I'm not going to go ahead and graph this one and give you decimals, but it would be a good thing to check to see what you get as decimals. and go set this equal to 0 and graph it, and be sure that those are the same as the zeros that you're getting on your graph there. Cheers.